Okay, so our topic is about the acids and bases. Based from our module or our recorded lecture, so there were two definitions of acids and bases. The first one would be the Arrhenius definition. So usually, itong Arrhenius definition of acids and bases, ito yung traditional na definition of acids and bases. So in the definition of acids and bases by Arrhenius, it is one of the definitions widely used until today. Okay, parang based on my experience nung kapag dun sa mga junior high reference books, ito pa rin yung ginagamit na definition ng acids and bases. And there are times as well na pati yung ibang teachers, ito pa rin yung ginagamit na definition. So how do we define acids and bases based on the Arrhenius definition of acids and bases? The first one would be an acid will contain hydrogen atom and dissolves water to form a hydrogen ion or the H+. So based on the Arrhenius acid definition of acids and bases, lahat ng acids ay merong H sa kanilang chemical formula. So for example here, in the decomposition reaction of hydrochloric acid, so it will dissociate it will dissolve into water to form a hydrogen ion. So as you can see sa ating chemical equation, nagdi-dissociate siya forming the hydrogen ion here sa product side. So lahat ng for Arrhenius acid definition, for the Arrhenius acid definition, lahat ng merong H sa chemical formula is considered an acid. Okay, and then when we talk about the base, for Arrhenius base definition, those compounds containing OH in the chemical formula will be considered as bases. Okay, so kung wala kang OH sa chemical formula, hindi ka considered as a base. That's the Arrhenius acid-base definition. Now, over time, meron namang somehow it predicts the behavior of the acids and bases during chemical reaction. However, there are some irregularities in the acid-base definition of Arrhenius. Kasi halimbawa, there are some compounds that they don't contain OH in their chemical formula. However, hindi nagbe-behave siya as a base. If we will base it on the Arrhenius definition, a base will always contain an OH. But example, some compounds like water can act as a base, and then ammonia or NH3 can also act as a base. However, if we will view their formula, ang water ay H2O, ang ammonia ay NH3, so it will not conform with the definition of Arrhenius of bases kasi wala silang OH. However, these compounds behave like bases in a chemical reaction. That's why, so as I have said earlier, H plus does not exist in water. Instead, it reacts with water to form the hydronium ion. And then, yung kagaya sabi ko kanina, yung NH3. Now, after scientists have discovered that some compounds do not conform with the Arrhenius acid-base definition, they tried to revise the definition. We have now the Bronsted-Lowry definition of acids and bases. So yung sa Bronsted-Lowry definition, when it is an acid, it is considered a proton donor. Now, if it is a Bronsted-Lowry base, it is a proton acceptor. So yung, paano natin malalaman kung siya ba ay proton donor or proton acceptor? So let's have this example, yung reaction between hydrochloric acid and water forming hydronium ion. When we say hydronium, ito ay H3O. Okay, hydronium ion and chloride ion. So how do we know if a particular compound will be a proton donor or a proton acceptor? So yung proton donor, for us to determine if it is a proton donor, let's look at the whole equation. Okay? So as I have said earlier, for us to determine if it's a proton donor or a proton acceptor, we have to look at the whole equation. So example here, we have hydrochloric acid sa reactant side. For us to determine if it is a proton donor acceptor, look at the counterpart of it sa product side. So ang counterpart nga ay chlorine. So based on this observation, nawala yung hydrogen doon sa chemical formula on the product side. That's why siya ay considered a proton donor. Okay? So from this reaction, we can say that HCl is an acid. Okay? And then if you look at the other part of the equation, we have here water, and then ang counterpart niya ay H3O. Nadagdagan yung kanyang hydrogen. Okay? So dahil nadagdagan yung hydrogen ng H2O, meaning H2O is the proton acceptor. Okay? That is why we can say that water here is a base. Okay? You might be wondering, bakit miss yung water yung naging proton donor, H3O yung nag-accept. So we are classifying muna yung reactant side of the equation. Later tayo magka-classify ng product side of the equation. Okay? But in here, as you can see, doon sa in general, H2O is the compound that will accept the proton. That's why it is considered as a proton acceptor. So as I have said earlier, the proton is donated by hydrochloric acid, and then it is considered a Bronsted-Lowry acid because it is the proton donor, and then water will be the proton acceptor. Okay? So, actually yung Bronsted-Lowry acid can be considered as para rin siyang Arrhenius acid definition kasi it contains a hydrogen atom. So technically, a Bronsted-Lowry acid must always contain as well a hydrogen atom. If you will look at the definition kasi ng Bronsted-Lowry acid and acids and bases as well as the Arrhenius acids and bases, magkakaiba lang sila sa bases. Okay? But always keep in mind that the Bronsted-Lowry acid must contain a hydrogen atom. So here are the common Bronsted-Lowry acids. By the way, this is the general formula for acids, the Bronsted-Lowry acid. So HA. Yung H of course is the hydrogen atom, and then yung A can be a non-metal or a metal. So here are some examples. We have hydrochloric acid, hydrobromic acid, nitric acid, sulfuric acid, and acetic acid. Now, you can also classify the acids based on their number of protons or as number of acidic protons. There would be monoprotic, diprotic, triprotic acids. So of course, how do we know if it is a monoprotic or a diprotic acid? You look at the number of hydrogen atoms. Of course, kapag isa lang yung hydrogen atom, we have the monoprotic acid. And then if there are two acidic proton or hydrogen atoms, that is a diprotic acid. And then for triprotic acid, there are 3 acidic protons. And keep in mind as well that Bronsted-Lowry acids may be neutral or it may carry a net positive or negative charge. So you might be seeing earlier, bakit may mga charges po miss doon sa chemical equation, bakit may naging positive but may naging negative. Okay, so but keep in mind in terms of acids, they can be neutral or it may have a positive or negative charge. Okay, now going to the Bronsted-Lowry bases, a Bronsted-Lowry base is a proton acceptor as we have established earlier, so it must be able to form a bond to a proton. So how can we say that it is a proton acceptor even if we don't see the chemical equation? One of the requirements to be considered as a Bronsted-Lowry base would be to contain a lone pair of electrons. So how do we know if it is a proton acceptor? We have to review our previous lesson in Gen Chem 2, yung ating molecular geometry, na we will determine if there is a lone pair in the central atom. Okay, so if a compound contains a lone pair of electrons and it accepts a proton, therefore it is considered a Bronsted-Lowry base. So example here, we have a reaction between ammonia, NH3, and water. So if we will look at the whole equation, ang NH3, here, ang kanyang counterpart dito ay NH4. So as you can see, nagdagan yung kanyang hydrogen, that's why it is considered the proton acceptor. Okay, so since siya yung proton acceptor, it is considered a base, yung NH3. And in here, yung H2O, naging OH siya. So, nabawasan yung kanyang hydrogen. That is why it is considered the bronze-lowry acid in this reaction. So let me just label it na acid para hindi tayo malilito. Okay, so this electron pair forms a new bond to a hydrogen from H2O. That's why it is considered the bronze-lowry base. Okay, so here are some of the most common bronze-lowry bases that we have. We have ammonia. So lone pairs make these neutral compounds bases. Ammonia, we also have water. Yung salts, we have sodium hydroxide, potassium hydroxide, magnesium hydroxide, and calcium hydroxide. Okay? So later, we will be defining ano ba yung kaya ng water. It can act as a bronze-lowry acid or base. Ano ba tawag sa kanya? Kasi bakit pwede siyang acid, bakit pwede siyang base? Okay? So, how do these compounds react, yung acids and bases? As you can see, ang general formula natin sa bronze-lowry base ay B with a colon. Okay? Ito yung general formula ng base. Bakit may colon? It will signify the lone pair of electrons that the base contains to accept the proton. Okay? So, in the reaction of acids and bases, again, we have the formula HA for the acid, and then B, yung B colon or colon B doon sa base. Ito yung general formula lang naman. Okay, as you can see, kapag yung acid dinadonate ng proton, it might somehow resemble, the product from the loss of a proton might somehow resemble the general formula for the base. And likewise, the product formed from the gain of a proton resembles the formula of an acid. Okay, so later we will be classifying yung product side naman ng equation. Kanina, nag-classify tayo ng reactant side. Later, we will classify the product side of the equation. Okay, so ito ay review lang nung ating pinag-uusapan kanina. Okay, so now, how do we classify the product side of the equation? So as I have said earlier, when an acid donates a proton, you will be forming here a conjugate base. So keep in mind that the product formed by loss of a proton from an acid is called the conjugate base. Yung counterpart ng acid, di ba ang acid ay nasa reactant side? So ngayon, yung counterpart ng acid doon sa product side is considered the conjugate base. And now, the product formed by gain of a proton by a base is called the conjugate acid. So yung counterpart, di ba, kaya nung nag-classify tayo ng reactant side, I told you to look at the chemical equation as a whole. Now, if we look at their counterparts, ang counterpart ng acid sa product side ay yung conjugate base, and then yung counterpart naman ng base ay yung conjugate acid. Okay, so always keep in mind that the product formed by the loss of a proton from an acid is called its conjugate base. And then the product formed by the gain of a proton by a base is called its conjugate acid. Okay? So example here, we have the reaction between hydrogen bromide and water forming bromide ion and hydronium ion. So if you look at the whole equation itself, ano ba ang counterpart ng hydrobromic acid doon sa product side ng equation? We have the bromide ion. Okay? And then, ano ba ang counterpart ng water doon sa product side? We have hydronium ion. Okay, so ako, actually, dahil sanay naman na ako sa chem, I can look at the equation kahit hindi ko tingnan yung counterpart. But as you are beginning with chemistry, let us assume that you are still beginning sa chemistry. So, mas maganda before you classify, you look at the counterparts muna. Okay? So if we look at hydrobromic acid and its counterpart, of course, in here, ang proton donor is hydrobromic acid. That's why it is considered the acid. And of course, the counterpart will be considered the conjugate base. Now, if we look at the other substances in the chemical equation, we have here water. So based from this equation, we can see that the water accepted the proton. That's why it is considered the base. Now, the counterpart water in the product side can be considered the conjugate acid, which is the product formed from the gain of a proton. Okay, so always remember the conjugate acid base pair. As I have said earlier, we can also see na yung water can act as an acid or a base. So ano bang meron sa compounds na pwede mag-act as an acid or a base? We call them amphoteric compounds. So when we say amphoteric compound, this is the compound that contains both a hydrogen atom and a lone pair of electrons. So it can either be an acid or a base. So example is water. So here's an example of water acting as a base. So when water accepts the hydrogen ion or the hydrogen atom, so it will become hydronium H3O, which is the conjugate acid. Now, water acting as an acid, if we remove the hydrogen from water, it will form OH or hydroxide ion, forming the conjugate base. Okay, so here are some examples of classifying whether it is an acid or a base, and then the conjugate acid and the conjugate base. So sa second example, we have here CH3COOH. Ano ba ang kanyang, this is acetic acid. And then, ang counterpart niya sa product side is CH3COO. As you can see, nag-donate siya, yung CH3COOH donated a proton. So it is considered an acid, while CH3COO is considered the conjugate base. Okay? Paki-spell out na lang kapag nag-worksheet kayo. Tapos, NH3, as you can see the other substances in the chemical reaction. So, NH3 and NH4. So, nag-accept siya ng proton. That is why NH3 is considered a base. And then, NH4 is considered the conjugate acid. Okay, so the third example would be the reaction between bromine and nitric acid, forming hydrobromic acid and nitrate ion. So in here, we can see the counterpart ng bromine is HBr, and then ang counterpart naman ng nitric acid is NO3 or nitrate. Okay, so based on this chemical equation, we can say that bromine accepted a proton. That is why it is considered a base, and its counterpart is considered the conjugate acid. Now, for the second one, or the other substances, HNO3 donated a proton. That is why it is considered an acid, and then the counterpart is considered the conjugate base. Somehow encountered na mayroong mga weak acid, mayroong strong acids. So how do we classify whether an acid is a strong acid or whether a base is a strong base or a weak base? So una-muna, a strong acid will form a weak conjugate base. Okay? So since it readily donates a proton, it will always form a weak conjugate base. Always remember, a strong acid will form a weak conjugate base. Likewise, a strong base will always form a weak conjugate acid. Okay? So how do we know if a compound is a strong acid or a weak acid? There is a table here that we use. So I think meron ito sa book ninyo sa chemistry. Iba lang yung design ng table na present ko kasi ibang book yung pinagkuhanan ko. Pero same lang yung content. Okay, gusto ko lang yung kulay ng table, ng book na to. Okay, so here's a table relating the acid and base strength. So for the acid, it is located doon sa left side, and then ang base ay right side naman. So the strong acids are located on top, while the strong bases are located in the bottom of the table, doon sa right side. So we can use this to classify whether the substance is a strong acid or a weak acid, or a strong base or a weak base. Okay? So, ano ba yung implications ng acid and base strength? Di ba during our kinetics and equilibrium lessons, we have talked about yung direction ng equilibrium or direction ng reaction, whether it is a forward or a reverse reaction. So now, when acids and bases react, it will also, a reverse reaction will also represent an equilibrium. So how do we know the direction of the reaction if there is an acid-base reaction? Always remember that the position of the equilibrium depends upon the strengths of the acids and bases. And always keep in mind that the reaction will always favor the formation of the weak acid. Again, the reaction will always favor the formation of a weak acid. So example here, we have the reaction between cyanic acid and hydroxide forming cyanide and water. So how do we predict the direction of the equilibrium? Unang-una, we have to classify, di ba, as I have said earlier, the reaction with all the equilibrium will always favor the formation of the weak acids. So, kailangan nyo muna maklasify sa reaction, sa chemical equation, alin ba dyan ng acid, alin ang base, alin ang conjugate acid, alin ang conjugate base. Okay, so the first step is to classify the acids and bases. If we look at this formula, yung HCN is the acid kasi siya yung nag-donate ng proton, and then its counterpart is Cn, which is the conjugate base. And then yung OH naman, it accepted a proton, that is why it is considered the base, and then yung kanyang counterpart is the conjugate acid. So we are done with the first step, classifying the products whether it is an acid or a base, or a conjugate acid or a conjugate base. Now, the second step is to look at the two acids. You have two acids here, yung HCN at saka yung conjugate acid na H2O. And then compare their relative strength. How do we know kung alin dyan ang strong acid at saka alin ang weak acid? You look at this table. Okay, again, ang ating acids ay hydrocyanic acid and water. As you can see, both of them ay weak acids. However, if we compare their relative strength, we can say that hydrocyanic acid is the stronger acid compared to water. So in that case, how do we know the direction of equilibrium? Always remember that the equilibrium will favor the production of the weaker acid. Again, in our case, it will favor the production of water as the weaker acid. So you might be seeing some references na unequal yung length noong reaction arrow. Mayroong mas mahaba compared doon sa isa. So whenever you see this kind of reaction arrow, always remember that the longer reaction arrow will signify the favor of the equilibrium. So in that case, di ba, we have established that water is the weaker acid. So the reaction will favor the formation of the products or the forward reaction. But in your worksheet naman, you don't need to have an equal reaction arrow length. So you can still practice yung equal reaction arrows. Okay? So in that case, in here, the weaker acid is in the product side. That is why the products are favored in the reaction. Okay, again, bakit nga ba products ang favored ng reaction? In an acid-base reaction, it will always be the formation of the weaker acid that will be favored. So I will be answering the examples. As I have said earlier, we have to classify first whether it is an acid, a base, a conjugate acid, or a conjugate base. Okay, so and here in the first example, so we can say that HF is an acid, and then its counterpart F is the conjugate base, and then OH is the base, and then the counterpart is water, which is the conjugate acid. So if we look at the two acids, ano ba yung acids dyan? We have the HF and H2O as the acids. And then if we go back to the table, if we compare their relative strength, so we have here HF, hydrofluoric acid, and H2O, water. So we can say that water is a weaker acid compared doon sa hydrofluoric acid. So in this example, in the first example, the formation of water will be favored since it is a weaker acid. So we can say here that the products are favored. Or ang direction ng reaction ay forward reaction. Direction ng equilibrium. Okay? And then, for the second example, We classify it again first. So NH4 is the acid here. Okay, para lang common ang label. NH4 is the acid, and then ang kanyang counterpart is the conjugate base, NH3. And then Cl here is the base, and then ang kanyang counterpart is HCl, which is the conjugate acid. So the two acids for this reaction is NH4 and HCl. Again, if we go back to the table, if we look at it, so we have here NH4, and then we have here HCl. Dito pa lang, we can say that HCl is the stronger acid compared sa NH4. That is why, in this example, the reactants will be favored. Okay, so reactants are favored here or the reverse reaction. Okay po. And then, for the third example, we have here HCO3, which is the base. Kasi ang kanyang counterpart ay nag-accept ng proton, so it is considered the conjugate acid. And then H3O here is considered the acid since it donated a proton, and then water is the conjugate base. So in here, the acids would be, nagkabaligtad na yung kulay, the acids would be hydronium ion and H2CO3. So these are the two acids. Again, if we go back to our table of relative acid and base strength, we have here H3O. Nasaan ang H3O? Ito ang H3O. And then H2CO3, yung carbonic acid. Okay, so we can say that carbonic acid is a weaker acid. That is why in this reaction, the products are favored. Okay, kasi nasa product side ang weaker acid or the forward reaction. So, kagaya ng ating kinetics and equilibrium discussion last time, there is also what we call the dissociation constant. So, recall na yung ating equilibrium constant K is equivalent to the concentration of the products over the concentration of the reactants. Now, there is also what we call the acid dissociation constant. Okay, so yung acid, since siya ay na-define, ng Bronsted scientists as those that completely dissociates in water to form hydrogen ions. So we have the acid dissociation constant K sub A instead of having K lang. Di ba? K ay equilibrium constant. So ang acid dissociation constant is K sub A. So yung K sub A, we omit water from the equation. That is why K sub A is equal to the concentration of the products over the concentration of the acid from the reactants. Okay po. So yung K sub A can tell us something about the strength of the acids and the acids. So the stronger the acid, the larger the K sub A value. And then the weaker the acid, the smaller the K sub A value. So, for example, if I will be giving you two K sub A values, so yung larger K sub A value will be the stronger acid, and then yung smaller K sub A value is the weaker acid. Okay po? So, ito yung examples ng K sub A. Actually, hindi naman kailangan siyang i-compute. Ibibigay lang din to as a table. Pero if in case lang na magbigay ako ng dalawang K sub A values na wala dyan sa inyong table, so i-compare nyo lang. The larger the K sub A value, the stronger the acid, and then the weaker the K sub A value, the smaller the K sub A value, the weaker the acid. Okay? So, there is also what we call the OH and the H3O concentration. Diba? We have established earlier na yung H3O concentration ay concerned with the acids, and then yung OH ay sa base. So if in case na meron tayong water dissociation constant naman tinatawag, yung water dissociation constant is equivalent to 1 times 10 raised to negative 14. Okay, again, the K sub W or the water dissociation constant is equivalent to 1 times 10 raised to negative 14. Kasi itong H3O at saka OH concentration, we can use the values of these to determine whether a compound is acidic, basic, or neutral. Okay, so we will work on that later. But how do we determine or how can we compare them? So we have to know the values first. So in case that H3O is given, tapos yung OH ay missing, if H3O is known and OH is missing, we calculate the concentration of OH by dividing the water dissociation constant 1 times 10 raised negative 14 over the given hydronium ion concentration. Okay? And then, vice versa naman, if OH is given and then H3O is unknown, so we calculate the hydronium ion concentration by dividing the water dissociation constant by the given hydroxide ion concentration. Okay, so these are the formula for OH at saka H3O. Okay po. So example, so we have to calculate the hydronium ion concentration with the given OH concentration. Okay, so example, we can have 1 times 10 raised to negative 6 molar, and then we also have 5.6 times 10 raised to negative 8 molar. Okay, so is there someone who wants to answer the first example? Okay, so to calculate the H3O concentration given the OH concentration, again, we will divide the water dissociation constant. So we have here H3O is equal to 1 times 10 raised to negative 14 molar divided by 1 time, wala pa lang unit. Unit ba yung kanina? Wala ata. So 1 divided by 1 times 10 raised to negative 6 molar. So in here, okay, so that would be equal to 1 times 10 raised to negative 8 molar. Okay, and then if we do the second example, okay, so in here, we have H3O concentration is equal to, again, 1 times 10 raised to negative 14 over 5.6 times 10 raised to negative 8 molar. So if we will have this computation, we will arrive at the answer 1.79 times 10 raised to negative 7 molar. So that is how we compute yung H3O concentration given the OH concentration. Okay. So how do we what do we do with these values? So as I have said earlier, we can classify whether a substance is an acid or a base based on their H3O and OH concentration. So as you can see here, if the H3O concentration is equal or equivalent to the OH concentration, we can consider the compound as a neutral compound. And then if the H3O concentration is greater than the OH concentration, it is considered as an acid. And then if it is if the H3O concentration is less than the OH concentration, it is considered a base. Okay, so if we go back to our example, if we compare yung ating, ito ay H3O, ito ay OH concentration, if we compare yung ating values, we have here the H3O and OH, and as you can see here for the first example, OH is greater than the H3O. Some of you might be confused based on my class last week. Parang confused sila po nagko-compare ng scientific notation. Pero kasi, ewan ko lang kung ito ay tama sa math ha. But kapag scientific notation ay kaysa mag-convert ako sa expanded notation, i-compare ko muna yung exponents. Okay, kasi di ba sa math, negative 6 is greater than negative 8. Correct me if I'm wrong, baka bano na ako sa math. Pero yun ang alam ko, negative 6 is greater than negative 8. So, we can say here, based from this example, that the OH concentration is greater than the hydronium ion concentration. That is why this compound is considered a base. Okay? So kasi kung expanded notation yan, we have here 0.0012345 6. And then for this side, we have 1, 2, 3, 4, 5, 6, 7, 8. So as you can see, greater even in expanded notation, greater ang value ng OH compared sa H3O. So for the second example naman, if we will look at this, greater ang H3O concentration compared sa OH. So kung yan yung expanded notation, we have here 0.1, 2, 3, 4, 5, 6, 7. And then this one, 1, 2, 3, 4, 5, 6, 7, 8. So as you can see, greater pa rin yung H3O concentration kapag expanded notation. That is why if H3O is greater than OH, we can consider this compound as an acid. So now, we also have what you call the pH scale. Okay? So yung pH scale, di ba naririnig naman na yan sa mga laboratory, pH ay acidic pH, yung basic masyado yung soil. So to calculate the pH, the formula for pH is negative log of the hydronium ion concentration. So ano ba ibig sabihin ng pH? pH is the power of hydrogen. Okay? So yung pH, meron tayong POH. Ang POH naman is the power of the hydroxide. So pH is, again, pH is the power of hydrogen and then POH is the power of the hydroxide. Okay, so kung ang pH ay negative log of hydronium ion concentration, ang POH naman is the negative log of the hydroxide ion concentration. Okay, so if we look at the pH scale, the lower the pH, the higher the concentration of the hydronium ion. Again, the lower the pH, the higher the concentration of the hydronium ion. So yung acidic solution kasi, ay, when we say acids, ang pH ay less than 7. Ito yung common misconception ng mga estudyante. Akala nila kapag mataas ang pH, mas acidic. But it's the other way around. The lower the pH, the more acidic the solution is. So yung pH less than 7 is considered acidic, wherein the hydronium ion concentration is greater than 1 times 10 raised to negative 7. And then, ang neutral solution naman is equal to 7, which is yung wherein the hydronium ion concentration is equal to 1 times 10 raised to negative 7. And then the basic solution is having the pH more than 7 or greater than 7, wherein the hydronium ion concentration is less than 1 times 10 raised to negative 7. So always remember these values and don't be confused doon sa pH number. So yung lower pH number ay acidic, ang higher pH number ay basic solution. Tapos kapag equal siya sa 7, neutral ang solution. Okay? So, nabanggit ito sa lecture video, sa recorded videos natin, na most of the citrus fruits, they have their pH at the lower range, meaning acidic ang mostly ng fruits natin. And then, yung tawag dito, yung ating mga household substances like the bleach products, the cleaning products, detergents, they are on the greater pH range or yung higher pH range, which is basic. So example here, if H3O is kung i-input nyo sa calcu yung log of 100, malabas nyo yung 2. Okay, so how do we input now yung sa calculator yung pH, to calculate the pH. So example, if H3O is 1.2 times 10 raised to negative 5 molar, so what is its pH? So i-input nyo lang sa calculate yung negative log of H3O or negative log of 1.2 times 10 raised to negative 5. Okay? So if you input that sa calculator, try inputting it sa calculator. So negative log of 1.2 times 10 raised to negative 5 is equivalent to 4.92. Yung ibang calculator, baka it will require you to have a subscript. Kasi may na-encounter ako ilang estudyante before na nangihingi doon ng subscript yung calculator. So kapag ganun, 10 ang ilalagay yung subscript. Okay? To arrive at that answer. Kasi di ba yung log ay 10, power of 10. Okay? Now, what if naman ang given ay pH, tapos you will find out the hydronium ion concentration. So baliktad naman. So pH of a solution is 8.5. What is the hydronium ion concentration? So there is what we call the anti-log. Kasi di ba yung, syempre ang ating pH is equivalent to negative log of H3O. So we have to manipulate the formula for us to determine or for us to get the H3O concentration. So in here, how do we manipulate the formula? So di ba pinakita ko kayo sa inyo yung ito, yung log of 100 is equivalent to 2. So now, how do we manipulate the formula? So halimbawa, di ba negative log of H3O concentration is equivalent to the pH. Okay? So syempre muna, we have to remove yung negative. So we divide both sides by -1. That's why you have log of hydronium ion concentration is equivalent to the negative pH. Okay? Now, for us to get the hydronium ion concentration, so we have H3O to get following the concept of logarithm, yung kanina kong present dito. Ito, following the concept, to get the hydronium ion concentration, we can say that log of the negative pH is equivalent to the hydronium ion concentration. Ito yung natawag nating anti-log. Okay? So how do you input it sa calculator? So let's say halimbawa, ang pH of the solution is 8.5. What is the hydronium ion concentration? So now, we raise 10 to the negative 8.5. Kasi di ba sabi ko nga sa inyo, hydronium ion concentration is equivalent to the negative log, to the log of raised negative pH, or 10 raised to the negative pH. Sorry. So 10 raised to negative pH. Okay? So, 10 raised to negative pH, yun yung anti-log. So to solve this problem, we raise 10 to the negative 8.5 and we will arrive at the answer 3.2 times 10 raised to negative 9 molar. So yun yung hydronium ion concentration. Okay, again, to calculate the hydronium ion concentration given the pH, so you raise 10 to negative pH value. So 10 raised to negative 8.5 is equivalent to 3.2 times 10 raised to negative 9. So, what do we mean naman by buffer? So yung buffer is a solution whose pH changes very little when an acid or a base is added. And most buffers are solutions composed of roughly equal amounts of a weak acid and the conjugate base. So yung buffer, kagaya lang din yan ng ating kinetics and equilibrium discussion, na merong mangyayari when we add a product or when we remove a reactant. So hopefully you can go over our kinetics and equilibrium discussion again to ito yung Leschetellier's principle, di ba? So if we increase the concentration of the acids, so meron din yang effect doon sa reaction like the Leschetellier's principle. Okay? So now we also calculate the pH of the buffer by using the K sub A or the acid dissociation constant. Okay po? So how do we calculate the pH of a buffer? First one muna, we all know how to calculate K sub A, pero given naman siya. But if we rearrange the expression to calculate the hydronium ion concentration given the K sub A, so we will multiply the K sub A or the acid dissociation constant given na siya sa table na ito. Ito siya sa table. Okay? So we will multiply the K sub A by the concentration of the acids over the concentration of the conjugate base. Again, we calculate the concentration of the acid over the by multiplying the K sub A to the concentration of the acids over the concentration of the conjugate base. Ito ay hydronium ion concentration pala. Tapos we will calculate the pH. So remember, pH is equivalent to the negative log of H3O concentration.